Hey guys, welcome back to the channel. Okay, in this episode, what we're going to end up doing is we're going to finish off the setting up the pipeline. There's only 3 functions left, and they're all pretty straightforward, so this should be pretty easy. Maybe even less than our usual hour time that we seem to be hitting it time. But yeah, this should finish it off. Before we get started, I want to do just a couple of quick things. Like I seem to do every episode, I want to go back and fix some code that I don't like. In Direct3D class, I made this constant. Static const uint frame count equals 2. Okay, so just a word about this. This is how I usually make constants. Because it's a member of a class, you have to have the static in. The static, of course, just means that no matter how many instances of this class I make, like if I were to make 8 instances of this class, they would all share this same. This would only get created once, as opposed to like a regular member variable, which would get created 8 times. Now, it doesn't matter so much for Direct3D class because it's singleton, but for this particular class, or I mean, for any other class, it would only use it once. And that you have to put it in. If you don't, I do believe you will get an error. Let me see. No, it actually works here, but it wouldn't work for something we're going to do later on. So, however, I'm going to say that the static const thing, as of C++ 11, there's a new way to do this, which is a little bit more preferred. Instead of using const, you use const expression, like such. From what I understand, the only difference between const and const expression is this is guaranteed to resolve at compile time rather than runtime. Const will, in some cases, resolve at runtime, and this will always resolve at compile time. So that's the difference. It's the preferred method now. They want you to use this for constants. So we'll go ahead and follow their lead and do that. Okay, so let's move on. We're going to go ahead and create our other 2 functions. So let's see. The last thing we did was, oh yeah, one other thing I want to do before we get started, which I neglected to do in the previous episode. So let's go back up here to initialize. We passed in window. Window is a handle from the win main. This should be constant itself. Let's try to maintain our const correctness. It's just a good idea. It's not meant to change in this thing, so we will, in fact, respect the const correctness thing. That way, if you accidentally change it, the compiler will tell you. If you accidentally changed it, that's a bug, right? So you want the compiler to tell you if you accidentally changed that. So we'll put those constants when they are appropriate, so that if I accidentally go in here and change window somehow, the compiler will complain and tell me, and then I'll realize, hey, I've made a mistake. So yeah, make sure to try to do that. It's a good idea. It is a little bit more of a bit of clutter in the parameter list, but I think it's definitely worth it in this case. It's always a trade-off, right, guys? So okay, I think we're ready to move on. The next thing we want to do after creating our swap chain is to create the descriptor heap. The descriptor heap is a chunk of memory on the GPU, which will accept the, I think it's the command queue. That's where it lives, I think. I think that's the deal. I don't know. These things I'm not an expert in Direct3D by any means, and these things are rather, I don't know, what's the word? They're, they're esoteric. Does anyone? I'm sure people understand it. I'm not one of them. I do it because it's required. So create descriptor heap. Whoops. Why am I putting in spaces? We don't want that. I don't think we need the window. For this, okay. So we'll go back up into here, and this is going to be a private function as well. Let me just make sure I didn't change anything. Yeah, okay. I can't do an actual direct one-to-one link up with my first build because I've got changes in the first build related to the asset loading that we're not doing yet. So it's a little bit tricky, but it's all right. We should be all right. Okay. For creating the descriptor heap, what we need to do is first fill out a heap description. So to do that, we're going to do a D3D12 underscore descriptor heap desk right here. The one we want. And we'll just call this heap description, like such. Okay. All right. Let's go ahead and start off by initializing that to make the compiler happy. And then we will fill it out. And there's only 4 members of this, and they're all relatively simple. The type is going to be a D3D12 underscore descriptor heap descriptor underscore heap heap type RTV heap type RTV. That's what we want. Honestly, I can't remember what this stands for, guys. It's a. Let me take a quick look. I'll just double check and make sure I understand what this is so that I don't say something that's wrong. Okay, yeah. So this is for the render target view. If you go over to the help page, this is the constants that we have. This is what we're using, the descriptor heap for the render target view. So it's the, it's what you are intending to drop over to the front screen once you've completed the back buffer. Okay, so heap description dot we'll do num descriptors. And this is where we need to use our variable frame count. So the number of descriptors we need is 1 per frame. So there you go. Heap descriptor dot flags equals. So we're going to make this D3D12 underscore descriptor flag none. It should be 0. That maps to 0. Yeah, it does. So no special flags for our heap descriptor at this point. Heap descriptor dot node masks is the last thing we need. Equals 0. No node masks. Okay, and that's all there is to that. So now we can do our function call. And this is going to come from the device. And we're going to say create descriptor heap. And then the reference to the heap description. And then the deal with this, the converter to our void, args, and then a reference to our descriptor heap. So we'll just call this the heap. Okay, now it doesn't know what that is, obviously. So we'll go back here to our pipeline objects, and we'll create a com pointer ptr to id3d. Let me see if I can find it. 12 descriptor heap. There it is. And this is the heap. Okay. And that should make that happier. And then we do this and we say the usual sort of thing. I'll just copy one of these because I'm just that lazy. Create descriptor map, create descriptor heap, create descriptor. There you go. Okay, return false. Very good. From here, we need to get to the descriptor size. So descriptor size, which we're going to make a member variable in just a minute, is device get descriptor handle increment size. And what we need to pass in is the descriptor heap type, which of course is just this same thing. Why do we need that? I'll show you that in just a little bit, but for right now, we're going to leave it there. Let's go back to our class and we'll make this, this is a pipeline object, so we're going to make it a uint descriptor size. And there you go. Okay, we'll just pick up our the size of each of the descriptor heaps. Okay, and then that's all there's to that. Return true. Very good. Okay, let's copy that, and we're going to go up here to our initialize routine and paste that in, and use all this stuff. Don't need this. We're going to say if not create heap, and the usual sort of thing. We'll just copy this out because again, just that lazy. And boom, done. Should be able to run that code, and it should work just fine. There you go. Took a minute for the diagnostics to come up, but sure. And there you go. Piece of cake. Okay, that's our first function, creating the descriptor heap. Okay. The next thing we're going to do, guys, is we're going to create another function called create render target view. Create the render target view. Okay, and again, once again, we'll drop this up into here. This is a these. And like such. Okay. We need to create the render target view. So right. Let me just take a quick look here. Okay. So for this, we're going to need a structure, and it's called D3D12 underscore CPU underscore descriptor handle. And it just changed it to D3D. I want CD D3D. It's gonna not like that, but we'll fix it in just a minute. Render target handle. Okay. It doesn't like this, and the reason it doesn't like this is because we haven't put in a thing. Let me see what the thing is that we're putting in. Okay, guys. This structure right here, this with the C. So there's a, if I lose the C, there's a D3D12 CPU descriptor handle inside of D3D12.h. However, we want to use C D3D, and this lives in a different thing. So I'm going to change this from D3D12.h to D3D12x.h. D3DX12. Oh, D3DX12.h. There we go. Okay, that works. Now you may wonder why we took out D3D12.h, because D3DX12.h already includes D3D12.h, so we don't need to include it again. But by using the X, that should fix this, I think. Although it doesn't seem to be. Let me just make sure. No, it still doesn't like it. Why not? Oh, because it check out my X. CD3D12X. No, CD3D12 X12. Good Lord. Okay, there it goes. So CD3DX12 underscore CPU underscore descriptor underscore handle render target handle. There you go. Jeez. That X can really throw you off. Okay, yeah, there we go. We're good. It's not turning purple, but it will, or it should in a minute, as soon as the compiler catches up. Okay, and there's a reason why we're going to use this helper function instead of using the standard thing, but I'll talk about that in a minute. So first of all, render target handle. We will do that, and then we're going to say render target handle equals heap, and we're going to call a function get CPU descriptor handle for heap start, like such. Okay, the only reason we're doing this is because if we don't, the compiler is going to complain that we have an undefined local variable, or at least I think it does. Local variables not initialized, yeah, if we don't put this in. So I'm just making the compiler happy. There's no real reason to do it. It's right here. Anyway, this function right here you can't use without the helper thing. So, but this maps ultimately to a D3D12 CPU descriptor handle. That's what that is. So that's the reason why we're getting that. Okay, so there's our handle. So we're going to say create frame resources and create a RTV. Create a RTV for each frame. So we're going to do a loop uint I equals 0, I less than frame count, I plus frame count. No, not frame count. Frame count. There you go. All right. Let's pull this up a little bit. If failed, swap chain. So we're going to access the swap chain, and we're going to call a function get buffer. That's not it. Get buffer. Okay, so the buffer number I, the IID PPV ARGS, and we're going to do a reference to render targets I, which is not going to know what it is yet because we haven't set it up. So we're coming to here into this area, and after the heap, we're going to say com pointer interface to D3D12 resource render targets, and we're going to do an array of frame counts. Okay. And it doesn't like that because it's not frame counts, it's frame count. There we go. And this right here, I think, is the one that's going to error out if we don't put in that static. Let me just check that, but I think that's true. Yeah, it doesn't like it when you do that. Constant expression is not valid here. It's got to be static. Otherwise, it won't take it. Okay. Yep. Lots of syntax errors, but that's because we haven't finished our function yet. So, okay, let's go here. Let me just make sure. I think we need another one of these. Yeah, there you go. Heck, it's so many of those. I can't track. 1, 2, 3, 4. Yeah, okay, 4. Okay, we got a failed state, so let's go ahead and fix that. The function is create render target view. The call is get buffer. There you go. Why is this giving me a problem? Render targets is undefined. Try to make it spelled right. There we go. Render targets sub I. Okay. All right. There you go. Now, so we have created a render target for each frame. So each of our buffers now has a render target. We're going to access the device and say create render target view and a reference to, no, not a reference, just a render targets sub I dot get. Okay, and then we need the comma. Then we need the description. We're just going to say null pointer. Nothing to put in here. And then the handle. So that's just going to be render target handle, like such. Okay. And that's a void call, so that it doesn't return anything. Okay, and then render target handle dot offset. So this little structure, or this little helper structure here, actually has a function in it. That may seem unusual if you don't really know C++ that well. Structures can have functions in them, just like classes can. Actually, in fact, if you don't know this, structures and functions are basically the same thing. The only difference is the default access level, right? For a class, the default access level is private. For a structure, the default access level is public. Now, in my case, I always put the publics up top because I want to see them first thing. So really, this is really no different than me doing this, right? It's the same thing. Totally would work. But yeah. I don't usually do structures with functions in them, but you can. There's nothing wrong with that. I, comma, descriptor size. Okay. So what we're saying there is move the render target handle to the next what do you call it? To the next buffer, or to the next target, right? Oh, so yeah, that's all there's to that. There shouldn't. I don't think this returns anything. Just a handle, yeah. Okay, very good. And return true. So what we've done here is we're creating a render target view for both of our frames, basically. That's what the whole purpose of that is. Okay. Did I call? I don't think I called that yet, did I? Make sure we call it. Otherwise, you don't know if it actually works. Sorry, what was the function name? Let's just copy it so I don't screw it up. Go. Paste it there. Looks good to me. And let's run it. Make sure everything runs okay. And again, we get exactly the same thing. But we are doing some work in the background. So yeah. We got a perfectly successful run. Our error list is clean. We're good. Okay. All right, guys. How are we doing on time? Half an hour. Okay. One more function, and this one is really very simple. And then our pipeline is done. We're going to create the command list allocator. So create the command list allocator. Create command list allocator. And grab this function, drop it in here. There you go, like such. And that should go away. There we go, thank you. This one's super easy. If failed, we'll access the device. Create command allocator. D3D12. Command. I don't know why it's. Can you get off there with that, please? Underscore. I lost it. List type. List type. Direct. Then an IID. PPV ARGS, the usual thing, and then a reference to the command list allocator, which we haven't created yet. Okay, create this. Copy that. Pointer D3D12 command allocator, command list allocator. And I can't spell com pointer because I've transposed the letters. All right, there you go. This, do I know what this does? Let me just take a quick look, make sure that I'm not going to mess this up. Create some command allocator. Yeah, it's not really going to tell me much. Creates a command allocator object. What does it do? I'm not really sure. The device creates the command list from the command allocator. Yeah, that's super unhelpful, but sure. We'll do it because it's required. I'm sure we'll be understanding later what this means, but right now, not going to worry about it too much. Again, we have an error state, so let's go ahead and deal with that. We'll just copy this in. Function is this. The call is that. And there you go. That's all there is to it, guys. Like I said, it's truly a straightforward one, even though I'm not really, honestly, quite sure what that is. We'll find out. We'll be using all these things. So all these things that we've created, well, not so much the debug controller. That I'm not really actually sure we need to keep that, but we'll keep it. The factory, which we use to create some of this stuff, we'll also use that to create some of the stuff in the allocate, the asset loader, I believe. Obviously, the device, which is a reference to your hardware, your GPU hardware. The command queue, which is the thing that you build, telling the GPU how to deal with the data that's about to get. The swap chain, which is the chain that holds together your two buffers, your back buffer and your front buffer. The heap, which is the memory on the GPU. Render targets, which is I believe those are the actual buffers themselves that actually end up being connected by the swap chain, I think. Could be wrong about that. And the command list allocator, which I really don't have any idea what that is, honestly. I'd tell you guys if I knew what it was, but I don't. Yeah, we'll figure it out. We're keeping also a descriptor size, which comes from here, the descriptor heap. So we're keeping a hold of that. And then the frame index, of course, is either going to be 0 or 1, depending upon which buffer is currently being shown on the screen. So yeah, those are the things we're going to keep. I'm going to label these pipeline initialization functions, just so we have kind of a, I don't know, a list of what they are. Yeah, that's it. I believe we have got it. This is not exactly what I have on my other one because, like I said, I've already started working on the next section for that. But I think it's right. I don't think I've missed anything. Let's go ahead and did we call? Let's go back up to the top. Called render target view. What was the last thing we made? Oh, we didn't even call it. Okay, yeah, let's do it. Let's call that. I'm being an idiot. We're calling create command list allocator. Okay, let's make sure we're calling all 7 functions. There's 7 functions. Right? 1, 2, 3, 4, 5, 6, 7. There's 7 functions. 1, 2, 3, 4, 5, 6, 7. Okay, let's fix this. Okay, everybody's good. No, you're not good. Sure, that's right. Create swap chain. I think we're good here. Okay, let's go ahead and save. We'll compile. We got a successful build. We have no warnings or error messages. Let's go ahead and run. And perfect. Good. We have a successful run. No warnings or errors down here. Let me just make sure my plus warning levels are set at 4. That's good. Okay. I think we are good here, guys. Yeah, the pipeline is fully initialized. The pipeline is ready to go. So the next thing we have to do is load our assets, and that is just as complicated and convoluted as loading the pipeline, maybe even more so. I've already started working on it, but I'm not finished with it, so it may be another week or so before I get another video up. Just depending upon how that goes. It is kind of complicated, so we'll have to go through that. I'm sure it'll take multiple sessions to get through because this one did, and the other one's just as long, like I said. So, yeah, a fairly long class, guys. It's 250 lines already, and we're only halfway through it. That's a longer class than you really kind of want, but it is my Direct3D class. We're basically going to set this up and then never look at it again. We'll come back to do some changes to the all these little structures when we get further into the program to be more what we want them to do rather than sort of this generic thing that we're building right now. But other than that, we're pretty much not ever going to look at it again. I'll be taking out these output debug strings, like I said, in the relatively near future. I think it's going to be the next thing we do after we finish the getting the initialization all finished. So yeah. Anyway, guys, that's all I really wanted to go over. So we are done here. So we will stop here, and I'll pick this back up in the next episode. So I'll see you guys in the next one. Thanks a lot.